Hello Ian. Alright, this is our video for our final project for Mastering Electronics. We decided to build a radio. So the four components that we have in this are a bandpass filter, an op-amp, a low-pass filter, and a potentiometer. So if you come over to the circuit, please, I can show you how everything works. So at this red spot here is where we have an antenna input. So the antenna was just a very long 25-foot long piece of wire that we just hung out the window. It picked up a broad range of frequencies so that we could use that as the input to our circuit. We then have a bandpass filter here constructed with a capacitor and an inductor. The bandpass filter limited the actual frequency range that was inputted into the circuit so that we would only get a very narrow range that would act that corresponded to a specific radio station. Next, that bandpass signal is sent through an op-amp, which amplifies the attenuated frequency range, and then the output of that op-amp is run through a low-pass filter, and the purpose of that is to get rid of any high-frequency noise that might be in the input signal. The last component is this potentiometer here, which is wired in with the op-amp for the second op-amp, and what that does is it acts essentially as a volume control. And so here we can show the theoretical output from our circuit. So what we've done is we've set up a network sweep. We put the input where the antenna would be, and the output's just connected to ground. And what we can see is that there is the right characteristic that we wanted. There is an amplified bandpass filter. Ooh, and let's see if anything happens as I change the potentiometer. Oh, that's bad. Lamau.
It just probably doesn't change it enough. I don't know. Oh, I mean, it is changing. Oh, it changed. It's higher now.
Yeah, okay. It was going to 20 decibels, but now it goes only to 10 decibels. Okay, so we reduced the volume. Thanks, Ian. Alright, Ian, I'm back with the potentiometer. The reason it wasn't working so well the first time we did it is simply because it's really insensitive to rotations. So you have to rotate the potentiometer a lot. So it started at around 10 decibels, and now it's slowly coming down. This is probably about, like, I'm doing maybe 5 turns in order to get it to drop a little bit, but you can see that after about 30 full rotations of the potentiometer, that we finally gotten to less than the input signal. Wahoo!